Hello everyone. So in this video, I'll be discussing the very final section or the very final topic of the chapter Permutations and Combinations, which is it's all about combinations. So in the previous two videos, I already discussed the idea of factorial notations, arrangements, as well as permutations. So we come to the final part of the chapter, which is about combinations. As I briefly mentioned in the previous video, when I talk about the idea of permutations, permutations are actually very similar to the idea of combinations. But then we saw it back then that the idea of permutations is also very closely connected to arrangements. It's like still talking about arrangements, but then there are some restrictions, right? You cannot use all the objects. Combinations is a bit different. In the case of permutations, if you still remember, the order matters. Right? Whenever you look up for the cases, for example, you want to take a group picture or you want to arrange books on the shelf. So all those things are talking about arrangements, and it should be very clear you are arranging, right? You are arranging. So the language matters, right? You are arranging. Be careful with the language and the keyword. But in the case of combinations, it's a different idea. In the case of this, the order is not important or considered not important. Okay, so you will see the examples later on. So in terms of permutations, combinations, they are actually similar, or you can say probably the same thing. The difference is that only the other one is order matters, while the other one, the order does not matter. In terms of the formula, if you recall previously, NPR is written as n factorial over n minus r factorial. And you see, it's also very similar. In the case of NCR, there's an addition of r factorial in the denominator. If you try to study this further and try to make sense of this, basically this r factorial is, the way I make sense of it is this. It's like the way we omit the possibilities to be arranged, or like that the order will be important. So you hopefully you will see why it is the case. Even if you cannot make sense of that, it's fine, as long as you can know or you can tell what the formula is and how to use it. So just simple examples on the formulas is, for example, like you have 5c2, it will be 5 factorial over 2 factorial 5 minus 2 factorial equals 5 factorial over 2 factorial 3 factorial. I don't know whether you can notice this easily or not, but which hopefully you did. But then if you try FC3, the interesting part is that you will end up with exactly the same result. So that's the uniqueness of combinations, or this is what they call as binomial coefficient numbers. So you'll have 5, 4, 3 factorial, 2 factorial, 3 factorial, so cancelled, so you got 20 over 2, 10. Then you try for the 5c3, you will get exactly the same. So everything else will be the same as the permutation. So let us move on with the examples. So let us look over the first example on the top. So in the case of this, the question is the following. How many different ways are there of selecting 3 photographs from 10 photographs? So you see, it's a bit different with permutations, but also it's a bit similar. In the case of permutations, if this is talking about permutations, you are talking about arranging. Right? So you have 10 photographs, it's a matter of you want to put it in a certain order, and then you will get 10p3. But since this is combination, in the case of this, see the keyword, they just select. It means we don't really care who comes first, who comes last. So in the case of this, we should put it as 10c3 instead. And then that marks a really important procedure in the sense of how you solve problems related to permutations, combinations. It's like the steps that you want to consider is that first thing first is that you want to consider, does the order matter or not? Why? Because if the order matters, then it helps you to make sense whether is it permutations or combinations. Then of course it will lead you to how you solve the problem, like which formula that you will use, and then how will you particularly solve the problem, right? So that is really important. So here 10C3 back here, you can solve it by using calculator, or simply you want to do it by using your brain, so you can do it without calculator. In this case, for example, like this, cancel, so you got 120. So you can do the same thing for question B and question C. So this is 7C5. You have available 7 books. You will only select 5 books or choose 5 books. Do not arrange them. You just select them. And in question C, a team of 11 footballers from available 14, which means it will give you 14C11. You can do it on your own in terms of the calculation, and you have to present the final calculation, the final result. Do not just present C75, that's it, or the 7P5 in the case of permutations. They will not allow you in the Cambridge exams. Okay, so I'll move on with the question number 2 and question number 3 in the examples. So you can pause this video first and then take a look. Try to do it on your own first, probably, if you wish. I'll put it here on the side. So I'll do for the question number 2, maybe. Number 3, maybe it will be too long for the video. You can try it on your own. So I'll go with question number 2. 4 pencils and 3 pens are to be selected. Again, selected only, not arranged, from a collection of 8 pencils and 5 pens. So you have available 8 pencils, 5 pens. So you see there are categories that you have 8 pencils and you want to take 4 pencils. And then you have 5 pens available and then you want to take 3 pens only. So then for the case of the pencils and the case of pens will be different, but they are connected with the keyword of and, right? So then if you think that it will be, it's just 13C7, sir. No, it's not. Why? Because if you go with 13C7, it means the number of the pens and pencils can be anyhow. We don't care. But this must be a very specific number of the pencil and the pens. It means it should be 8C4 and 5C3. And then not only that, the total must be also multiplied. Okay? Not only that each of them you calculate, but you have to multiply all of them and you get the result. Okay? So once again, it's not combining the two numbers. You have to do it separately and then you multiply it after all. So I think I still have some time for the third number. A committee of 5 people is to be chosen from 6 women and 7 men. Pretty similar with the question number 2. So I'll use another color for this. Find the number of different committees that can be chosen if there are no restrictions. See, no restrictions. It means you can do it however you like. Now in such a case, it will be 13C5, as you might think in the first place for question number 2, because there is no particular restriction. You can just calculate this one. But then question B, there must be more men than women. What does it mean by more men than women? But you need 5 people, right? So one way to do it that I like is that I put it as like a table. So sort of like this. So I need more men than women. So that means it can be 5 men, 0 women, right? No one. So then 5 is more. Definitely it can be 4, 1, and 3, 2, and then that's it. As long as the men is more than the women, right? So for the case of this, it will be 7C5 times 6C0. Similar to the second number on the left. So you have to calculate for each and then you multiply all of them. 7C4 times 6C1. Then last but not least, 7C3 times 6C2. And for each of this, you calculate the result. And then the thing is, because you have like case number 1, case number 2, case number 3 is like this or that. After all, you have to add all of these numbers. That's it. So if you are still confused, try to review the video again, replay the video again, or stop here and there, and then try to make sense of any of the problems, especially because they will make it better instead of just look at the formula. So hopefully that's helpful. Thank you guys. All the best in your learning journey for this chapter.